Today we're going to start our first lesson that's completely 7th grade. It is called Sets and Subsets of Rational Numbers. And in 6th grade, y'all started learning this? Yes or no? Yes? And so we're just going to kind of extend what we learned from last year. So the first thing I want to talk to y'all about is what a set and a subset is. Have y'all ever seen a Venn diagram? Yes. Okay, and in a Venn diagram, whatever falls inside of another circle or square or something is called a subset. Does that make sense? So, for example, if I have the title Bay City ISD, and that's the big Venn diagram title, then everything in here has to be what? A subset of Bay City ISD. So I would have Cherry. What else? Tenny Holmes, THE. What else? Bay City Junior High. Now, under Bay City High School, I might have the stadium. The stadium. The stadium is a subset of Bay City High School because it's a part of Bay City High School, yes? The stadium is also a part of Bay City ISD. So if I was talking about the stadium, you would say, well, it belongs to Bay City High School, but it also belongs to Bay City ISD. If I was talking about Bay City Junior High, then any student in Bay City Junior High I could put in this category, but they also fall under Bay City ISD. Does that make sense? Okay, so when we're talking about sets and subsets, the set here is Bay City ISD, and these are all subsets that belong to that. And the stadium is a subset of Bay City High School, which is a subset of Bay City ISD. So basically, the more you get inside, the more categories it actually belongs to. Does that make sense? Yes or no? Okay. So that's kind of what we're talking about today, sets and subsets. So our big picture in 7th grade is rational numbers. Because in 7th grade, we're only going to learn about rational numbers. In 8th grade, you learn about irrational numbers. Okay, and the big category in 8th grade is called real numbers. And then when you get to high school, you learn that some numbers aren't even real, they're imaginary. But in this class, we're only going to be talking about rational numbers. What is a rational number? A rational number is a set of numbers that can be expressed as a ratio. So pretty much any number in this class is going to be rational. They are numbers that can be expressed as a ratio. What does that mean? Fractions, whole numbers. Can a whole number be expressed as a ratio? How? What? Like 5. How would I express that? 5 over 1. Yes, so whole numbers. How about integers? Can integers be expressed as ratios? -5 over 1. Yeah, so integers. And then the other one is you're repeating and terminating decimals. Can decimals be expressed as a ratio? So can 25 cents be expressed as a fraction? 1/4, yes. So any of these can be expressed as a ratio. They are rational. Got it? So our big category is going to be rational numbers. That's what would be in the spot of Bay City ISD. Okay? An integer is a subcategory of rational numbers. So I want y'all to look. This and this are subcategories of rational numbers. That's why they have their own definition. What is an integer? An integer is a positive or negative whole number, no fractions, no decimals. Again, an integer, they're the numbers you put on a number line. 1 and -1, 2 and -2. So if y'all look at the number line up there on my whiteboard, all of those numbers are integers, the positives and the negative counting numbers. Is that good? And these are subcategories of rational. All right, what's a whole number? It's a positive integer. Only the positives. A positive number, no fractions or decimals. So they're the numbers on the number line that are only the positives. Whole numbers include 0. Oh, we forgot to put examples. So go back to integers. So an example of an integer, -3, -2, -1, 0, 1, 2, 3, and you could keep going forever both ways. No, a 0 is never a negative or a positive, but it is an integer. Because integers are all the numbers on the number line that aren't fractions or decimals. A whole number, your positive numbers, including 0. Including 0. So whole numbers, 0, 1, 2, 3, and it keeps going forever. So if I ask, is 256 a whole number, you would say yes. A whole number is a subcategory of integers. Got it? Because all whole numbers are integers. Got it? Okay. A natural number, I think this is the new one for y'all. A natural number, also called counting numbers. Write that down. Also called counting numbers. Oh, we have that right here. Also called counting numbers. A natural number are your positive numbers that do not include 0. That do not include 0. So they're basically your whole numbers minus 0. Yes? And then we already went over what a set and a subset is, but let's just write it down. A set is a group or collection of things that belong together, resemble one another, and are usually found together. A set is a group or collection of things that belong together, resemble one another, or are usually found together. A subset is part of the larger group. So again, Bay City ISD is the set. All of these are subsets. They're part of Bay City ISD. They're just more specific. So if you flip to the back, I have put out for you a Venn diagram with our vocabulary words. What is the main set of this called? Rational numbers. That means anything in this chart is rational. Yes? So over here, my rational numbers, this can be anything. Fractions, decimals, whole numbers, integers. But if they're integers, we would specifically put them in the subcategory for integers. Does that make sense? Okay, if they're whole numbers, we would specifically put them as a whole number, and if they're counting numbers, we would specifically put them as counting. But counting numbers are rational. Counting numbers are also whole. They're just more specific. Yes? So what we're going to do with these numbers is we're going to place them in their best spot. Can all of these numbers go right here for rational? Yes. But that might not be the best spot for them. Okay? All right, let's start with 0. 0 is definitely rational. Yes? Okay? Is 0 an integer? Yes, it is. Is 0 a whole number?
Yes.
Yes. Is 0 a counting number?
No.
So what's the most specific category that it belongs to? Whole. And then I just mark out that I did it. So I always start with the biggest one and just keep asking myself and then go till I can't go anymore. All right, 8.7. Is 8.7 rational? Yes. Is 8.7 an integer? Let's look at the definition of integer. An integer is a positive or negative whole number. No fractions, no. All right. Is 8.7 an integer? So where should I best put it? So anywhere in the rational part. Negative 45. Let's start here. Is negative 45 rational? Yep. Is negative 45 an integer?
Yes.
Yep. Is negative 45 a whole number? Because whole numbers are only the positives and zeros, so no. So I have to best put it as an integer. $12. Is 12 rational? Is 12 an integer?
Yes.
Integers are numbers on the number line. Yes, it is. Is 12 a whole number? Yes. Is 12 a counting number? Yes. So what's the best spot for 12? Counting. So I'm going to say this again. If a number would be counting, the answer is yes to everything. If a number would be whole, the answer is yes to everything like that, just not counting. Okay, here we go. Next one. Negative 5. Is negative 5 rational?
Yes.
All numbers in this class are rational. So yes. Is negative 5 an integer? Yes. Is negative 5 whole?
No.
No. So the best spot for it is integer. 3.2. Is 3.2 rational?
Yes.
Is it an integer?
No.
Integers cannot have fractions or, so 3.2 best goes under rational. 412. Is it rational? Yes. Is it an integer? Yes, because it's a positive or negative. It would fall on the number line, yes? All right. Is it whole?
Yes.
Yes. Is it counting? Would you eventually count it?
Yes.
So 412 would best go under counting. 13. Where would it best go? Counting. So question. Is 13 also a whole number?
Yes.
Is it also an integer?
Yes.
Is it also real? Sorry, rational. Okay. Sorry, that's 8th grade. Sorry. That's 8th grade. Okay. Yes, it is real. Okay. All right. 25. Counting. Negative 120. Integers. Okay, this is a trick question. Negative 80.4. Rational. And every year I have students say it's an integer because it has a negative. What are they doing? Integers cannot have decimals or fractions. So it is just rational. Do y'all understand that though?
Yes.
Do not think because something has a negative sign that it's an integer. That's very, very wrong. Okay? It cannot have a decimal or fraction. All right, negative 155. Why was that one an integer? Because it's a negative or positive counting number. 12. We already did 12. I don't know. I don't know why that's on there again. All right. Well, we know it's counting. It's also whole. It's also integer. It's also rational. 18. Counting. 35. Counting. Negative 1. Integer. Positive 8. Counting. 23 cents. Rational. Negative 9. Integer. 147. Counting. 38. Negative 12.7. Rational. But it has a negative sign. It's a decimal. Very good. So it is not an integer. 92. All right, I'm going to give y'all a trick one. I want y'all to write this number down, and then I want you to figure out where it would best go. Think about it. Don't put it there yet. Don't say it. Think about it. Are y'all ready? 12 thirds. Don't say anything. Write it down. Think about where it should go. It is a trick question. Who has an idea? What do you think? Brianna, what do you think?
I think it's a counting number.
But it's a fraction.
Yeah, but
If I simplify 12 thirds, it actually turns into 4. 12 thirds is a counting number. Is that what y'all got? No? Do y'all see it now? How many of you thought rational? And you're right, because they're all rational, right? It's not the best place because it simplifies to 4. So listen, when you're doing this, you have to ask if this number can be simplified to something. Make sense? I'm going to do one more and then y'all tell me now that you have an idea. Negative 25ths. Y'all were supposed to let him think. He's correct. Why is negative 25ths an integer?
because it's negative and it can be turned into.
What is negative 25ths? Negative 4. So it would go here because negative 25ths is actually negative 4. All right, let me pass out your assignment. All right, this assignment looks really long, but it's super easy. That's why it's longer, okay? Here, you're just going to tell me what they are. It's literally from your notes, right? Here, you're going to place them in their best spot. Don't try to cheat and put them all as rational, okay? Because that's not all their best spots. Okay, flip to the back. Here, you're going to say true or false. And honestly, guys, the best way to do that is by looking at the Venn diagram. Okay? Here, you're going to write their best set, like their best subset. What do they best fall under? You don't have to write all that apply to them. Write their best one. Okay? Put them in the Venn diagram. True or false. Pick the Venn diagram that is correct. And that's it. All right, you may start.